Okay, in this video we will be talking about the triangle proportionality theorem, which states a line parallel to one side of the triangle separates the other two sides proportionally, and the converse is also true. What that means is that if I have this line through the interior of the triangle like so, and it is parallel to any of the three sides, then that means that BC, which we'll highlight in yellow here, is proportional to DC. Okay. It also means that AB is proportional to DE, okay, or ED. It also means that the whole side, AC, is also proportional to the whole side, CE. And what we mean by proportional is that I will have the same common ratio for each fraction. Okay. Another thing that we should point out is that because we have parallel lines, if I extend this line and extend this line, I now have a transversal from unit 3. I have a transversal, which means that this angle is small, this angle is small, and if we know anything about two small angles, we know that part equals part. These are also corresponding angles. And because they're corresponding, we can come over here and say that this guy is a transversal. We have another small and another small. And we could say that these angles are also corresponding, so they're set up as part equals part. Because we have two angles in each, the big triangle and the tiny triangle, that are congruent, we can say the two triangles are similar, and that's why the sides are proportional. Okay? So by AA similarity, like we talked about in 3.2, we could say the triangles are congruent, and therefore their sides are proportional since they're similar. Okay? So if you notice, the angles on the same side, the top and the middle one, are congruent. We do not say that C is congruent. So wherever the parallel line is, the two angles that touch the parallel lines are going to be congruent inside the triangle on either side. But they are not congruent to each other. Notice that I have one arch mark here and two arch marks here. It's going to be really important for y'all to use later in your practice. Speaking of practice, let's do this guy. We have this picture here. We have our parallel lines, which means that 3 is proportional to 9. Yes, I know that looks like a Q, but it's a 9. Okay? We also have X is proportional to 6. So if we set up our fractions, I have 3 over 9 is equal to X, sorry, not X, 6 over X, because we have our small triangle over our big triangle. Okay? When we do that, we do what we've been doing, and that's cross multiply. So we cross multiply, I get 3x, and I get 54. So 3x is equal to 54. Now I could have simplified that fraction and had it be equal to 1/3 and then cross multiply. And that would probably be the easier thing to do, but we can still do it this way. And I get x is equal to 18. And that's it. That's all we do. Down here at the bottom, we have the same thing. Once again, we have 10, which is my small triangle left, x plus 6, my small triangle right, so they're going to set up one fraction. So 10 over x plus 6. This is, in fact, a plus. Sorry, I did not copy well. And then we have 2 and x. And so when we do this, we get 2 over x. Notice I'm staying consistent and keeping things together. I cross multiply. And notice I'm going to have 2 times x plus 6. So I need to make sure that I put x plus 6 in parentheses because I need to distribute in order to do this correctly. So I get 2x plus 12 is equal to 10x. I subtract 2x from both sides so that all my x's are on one side. I get 12 is equal to 8x. And when I divide by 8, my fraction simplifies and I get x is equal to 3 halves or 1.5 depending. Okay? And that's all we are doing with the triangle proportionality theorem. So again, if I have a parallel line inside the triangle that's parallel to one of the outer edges, then the sides are proportional to each other. And the angles on the interior will have a congruent pair that is corresponding.